This is a 5 day a 5 day program. So in these 5 days, we will discuss what is AI, what is agentic AI, how it works. So all these are, all these are very latest steps. Okay. So before going to the details of LLMs, agentic AI, MCP, etc., you need to understand what exactly AI and what exactly or what is the difference between the AI and the agentic AI, how it works, etc. So in today's session, I will discuss, or I'm going to present what exactly AI is, how it evolves, how the modern systems like agentic AI and all differs from the traditional AI things. Okay, so this is the agenda of today's presentation. So first we will discuss what is AI, then we will see how AI is evolved, then we will we will see some basics of generative AI, what exactly is generative AI. Then of course when we talk about generative AI, we need to discuss what is LLMs, so the large language models. So there are open and closed models we have. So we will discuss those, and the most importantly, the architecture behind generative AI, that is transovers. Then, if you want to communicate with the LLMs, of course, you all are prompting with GPT, Gemini, etc. But when we are developing an application using these LLMs, there are some standard ways to prompt. So we will discuss what exactly prompt engineering, and then we will see how to build an application using LLM. And finally, we will discuss agentic AI. And recently, we have a protocol to communicate with the agentic system, that is MCP, Model Context Protocol. And we will see some use cases also. So I think it is better to start with the definition of artificial intelligence. Yeah, I know you all are familiar with this term, right? Artificial intelligence. So basically, when we talk about artificial intelligence, uh, actually we are trying to mimic the human intelligence, right? So actually, yeah, if you want to, what exactly we are trying to do? We are trying to mimic how human think, how human behaves. These are the main idea behind artificial intelligence. So we are trying to mimic human intelligence using machines. Okay, especially the computer systems. So yeah, being humans, we have many capabilities like learning, reasoning, problem solving skills, and perception, and also the language understanding, right? So day by day, the AI is gathering many capabilities. So initially, AI have uh, very limited capabilities to understand some specific things only, right? But later, when LLMs are on the scene, it has some some more capabilities like language understanding, the problem solving, especially the reasoning, etc. Right? So basically, the human has all these things: learning, reasoning, problem solving skills, and etc. And now we are actually in AI era. They are actually trying to mimic all these things. Okay, so based on these things, we can classify AI into many categories. Basically, but we can say that one is narrow AI, and second one is general AI, and third one is super intelligence. So narrow AI means when if the AI system is designed and trained for some specific task, okay, then we can call it as narrow AI. So when I'm talking about a narrow AI, many of you may think that GPT is narrow AI or general AI. So, but we can say that GPT is narrow AI because still it has some limited capabilities only, or it is designed to do some specific task. So what is the main task or main purpose of GPT? It is for generate, right? So that is the purpose of GPT. So we can call GPT as a narrow AI thing. But when we are talking about uh, general AI means as we do. they have the capability. They will have the capability to do some common tasks like human level tasks, like cognitive abilities, capable to versatile learning, and applying intelligence across diverse domains and diverse tasks. Okay. Actually, what we can do, we can gather information or we can gather knowledge from one domain and we can apply it in another domain, right? So that cognitive abilities and versatile learning capability will be there in general AI. Okay. And and actually, the third thing is basically super intelligence. That is not near in maybe not in near future. It may happen. Future intelligence, it will surpass the human intelligence actually. So the narrow AI means it is the ability is less than human intelligence. In general AI, it is almost equivalent to human intelligence, and in super intelligence, it is above the human intelligence. Okay, so we can classify the AI things or AI systems into narrow AI, general AI, and super intelligence. Actually, one of the when we talk about the AI history, uh, okay, when we talk about AI history, actually, we can in 1997, IBM built a system called Deep Blue. You may heard about it, Deep Blue, and it was one of the most uh, brilliant system at that time. And actually, it defeated at it defeated that time world champion Gary Kasparov on a chess competition. Okay, and at that time people thought that yeah, machine become intelligent, and in near future it will surpass the human intelligence. But as a science point of view, what was the reality? Actually, if we can say that deep Deep Blue actually didn't understand a single move in chess. Okay, but what it has done, it has collected millions of moves using fixed rules. It has collected millions of moves using fixed rules, and based on the moves that is already stored, it has take decisions. Okay, so that is the old AI fashion. But in the new AI or modern AI doesn't follow rules. So when you use GPT and all, you can say that it doesn't follow any rules. Okay, the main thing is if you give the same prompt twice, you will get different answers. So we can say that it doesn't follow any particular rules. Okay, so that is the idea behind modern AI. In old AI, we have developed the old AI is developed based on fixed rules. Maybe suppose if you want to create a system that can play chess, we have to write hundred lines of codes, and we have to include thousands and thousands of moves. Okay, so that was the old fashion. But in new fashion, actually, it doesn't follow any specific rules. And if you talk about the branches of AI, we have different branches like machine learning, deep learning, NLP, computer vision, generative AI, and now we have the agentic AI also. Okay, so what is machine learning? Or we can say that classical machine learning. So at the era of classical machine learning, we have a lot of algorithms, the classical machine learning algorithms that can do simple tasks, right? So we can say that we have supervised and unsupervised algorithm, and that can be trained on specific data, and we will get some information or some inferences. Okay, that is basically the classical machine learning algorithm. Later we have deep learning, the convolution neural network and all. So when convolution neural network and all comes on the scene, we were able to do more complex tasks like object detection, image classification, etc. And at the same time, NLP was also evolved. We have algorithms like BERT and all. And using those algorithms, we were able to do some natural languages, or we were able to process natural languages. And of course, when deep learning was evolved, computer vision, there was a new field called computer vision. So in computer vision, it actually mimics the human vision, how human perceives the scene in the same way the computer was able to perceive the scene. Okay, so behind the computer vision, we know the the fuel is actually the deep learning. And when after that, actually, the LLM was introduced. So when LLM was introduced, we have the generative AI and agentic AI, and we are going to discuss more generative AI and agentic AI in this session. So according to the statistics, actually, a human being uses AI at least 100 times per day. Suppose you are using your mobile phone. When you are using your mobile phone, if you want to unlock the mobile phone, you can use the facial recognition. It is a very simple AI algorithm. And if you are using Google search, it also uses a lot of AI algorithms behind. Then YouTube recommendation system is basically AI. The spam filtering, Google Maps, voice assistant, and of course the chat GPT and AI chatbots you are using. All these things are basically the AI. So let's see how AI was evolved. So initially we have the rule-based systems. So in the rule-based systems, we have to write, we have to manually identify the rules, and we have to include all possible logics. Okay. So based on the logics we have written, the system will follow. And later we have the machine learning in the ML era. We have some data sets. We have some algorithms with limited capability. So these algorithms will be trained on this data set, and we can do simple tasks. And of course, then deep learning, generative AI, and agentic AI we have already seen. Okay. So what is the main difference between the old-fashioned rule-based systems and modern AI? Suppose uh, you're a banking person, okay, and you have to approve the loan. So in the old fashion, we have some rules. Suppose if the salary is greater than 50,000, then approve the loan. That is the that is the fixed rule. You can't change it, okay, or it can adapt with the circumstances. But in modern AI, or or in agentic AI or LLM based AI, what we can do, it will identify the patterns, because the loan transaction data, a lot of millions of loan transaction data are available with the bank. So there will be a system that is trained on all these historic data. Okay, so there will be a model that will predict when a user comes, or when a customer comes. It will collect the credentials from the customer, and it will predict based on his past experience, or the system's past experience. It will predict whether the loan will be approved or not. So it can adapt with the circumstances. That is how this modern AI is working. So before that, we can say that the traditional AI. Suppose we can consider traditional AI is like a CCTV. Okay, so if you are building a computer vision system, and if we have a dog image, there was a classical problem in object detection, dog versus cat, right? So if we give an image, it will detect whether the image is cat or dog, right? It cannot generate anything. But when Gen AI comes, what we can give, if we can give a prompt like draw a dog that is playing a guitar, okay? So if you give a prompt like this, it can generate a brand new image for you. Okay, according to your imagination, you can create images, text, code, audio, and video. Okay, so we're actually the generative AI models. Okay, so generative AI means AI that can create, not only create, generate, right? So generate means what are the things it can generate? If you ask something to GPT, it will generate answers for you, or it will create answers for you. And of course, you might have used Nano Banana, right? So if you give a prompt, so if you give a prompt, it will create an image for you. Okay, based on your imagination, or according to your imagination, you can create beautiful images. So recently, one trend is going on, like, so if you ask GPT to create a caricature of you based on the things that GPT knows about you, okay, then it will create a beautiful caricature of you based on your past chats or past prompts. And of course, the next application is coding. Okay, it can create beautiful codes. It can create wonderful codes for you. There are a lot of AI coding techniques AI coding platforms are already available. Some of them are War. You may have heard about Cursor, War, and recently the Anti-Gravity by Google. Okay, so these are the code AI coding platforms available. And of course, it can generate audio and video. Sora, you might have used Sora for video generation, and Whisper is there for audio also. So the main difference is the old AI is basically discriminative, and the generative AI is more interactive, or it is generative basically. So discriminative means actually the discriminative models can classify or predict labels from given input data. So we have, yeah, the supervised learning. We have the X and Y, right? So based on the data, it will predict the Y. So when an email comes, it will predict whether it is a spam or not. Okay. So as I have already mentioned, when an image comes, it will predict whether it is cat or dog. But in generative AI, you can generate the content. Suppose you want to write a mail to your client, you can write a personalized mail. If you want to create a report, you can just prompt create a detailed report based on the data you have given. And if you want to generate image, just prompt it to generate an image. So it can generate, but in discriminative AI, it can decide based on the data what is the label. Okay, that is the difference between discriminative and generative AI. And the popular generative AI tools, for text generation, we can use ChatGPT, Claude, Gemini, and many are there actually. DeepSeek is there, Llama is there, Grok is there. Many LLMs are currently available. And for image generation, we can use GPT and Gemini. Other than that, we can use Midjourney, Stable Diffusion, etc. And for code generation, as I have already mentioned, you can use Git Copilot, WAR, then Google Anti-Gravity. Cursor is also there. Now let's see what is large language model. And these we can generate or we can create all these things, right? We can create text, images, code, videos, and audios. And what is the thing behind all these things? So when we take ChatGPT, we are getting an interface, right? Through the interface, we are talking, we are prompting, right? So there should be a model. There should be a model behind all these things, whether it may be Gemini. or GPT, there should be a model. That model is basically called large language model. Okay. So large language model, the term itself explains what is large language model. Okay. So there is an architecture behind this large language model that is known as transformers. Okay. So what is large language model means? This transformer architecture is trained on huge amount of data. Huge amount of data means it is very, very huge. Massive amount of training data is used. Okay. So the architecture, the transformer architecture, that is a very beautiful architecture that is trained on massive amount of training data, and it has the capability to generate something. Okay. So when the transformer architecture is trained on this massive amount of training data, we will get a model. Okay, we will get a model. That model is basically known as large language model. Okay, so this large language model is the strength behind all all platforms we know, like GPT or Gemini. Okay, and the other thing is we can fine tune this large language model. We can further fine tune this large language model to do some specific tasks. Suppose we want to fine tune it to do some specific, some domain specific task. We can give the data, we can train it, and we can use it. Okay. So the architecture behind this large language model is basically the transformer architecture. Keep that architecture in mind. We will discuss transformer architecture in detail. So before that, we will see how the large language models are evolved. So actually, there was a paper called "Attention All You Need." You might have seen that paper. So it was actually introduced in 2017, but the well-known large language model or remarkable one was introduced in 2020, that is GPT-3. Okay. Then in 2022, we have GPT, Chat GPT, and after that, we have Gemini also. And recently, in 2025, the multi-models are introduced. So what is the difference between multi-model and all GPTs? In old GPT was able to process or generate text only, whether it may be Gemini or GPT, it was able to generate only text. But in multimodal era, it can generate text, images, audios, and videos. So that is the difference. So within these 5 years, you can see the significant progress in LLMs research. Okay. So that means initially it was able to process only some text. At that time, we have used it for writing mails, creating reports, etc. But now it has the multimodal capability. That means it can understand the scene. It can understand what is the content of the video. It can understand what is the content of the image. Okay. So what we can do, we can create application using these capabilities. That is the difference. Many of you have used GPT and Gemini uh, only for prompting, right? That means basically to clear your doubts or maximum as an assistant, right? But, but what is the exact application or what is the exact relevance? The relevance means before this LLMs comes, there are lot there were lot of untouched areas in the industries across the industries. Okay, we can't do anything. We were able to we were actually not able to touch all those areas because it was the problems were very complex. Specifically, if we can say banking domain. Okay, in banking domain, they have lot of legacy data. They have lot of legacy data, maybe in digital format or in hard copy also. And if they want to digitalize, actually in the name of digitalization, what happens? They have scanned all these things and kept it in a drive or something in a storage device. But those data were not useful because we cannot use it before LLMs comes. But when a multimodal LLMs are on the scene, we were able to extract useful information from those data. So from the data, we have created information using this multimodal. Okay, actually that created lot of business values. So let's see how the LLM revolution is going to transform business. According to the studies, the projected market cap of the LLMs will be $36.6 billion by 2028. Okay. And according to the 2026 25 December statistics, only 30 to 40% enterprises are adopted these LLMs or the generative AI. But by 2028, almost 80% of the industries will adopt LLMs, and it will help them to reduce reduce the processing time up to 40 to 60 percentage, especially in banking and all. It will enhance the productivity. It will, of course, when the processing time reduces, of course it will helps to improve the productivity. And when LLMs came, initially we have created chatbots using LLMs. Now you can see the AI assistant or AI powered chatbots in almost all websites, right? So before LLMs, you remember the old fashioned chatbot. It has some limited capabilities only, right? So there are some predefined questions and predefined answers. And if we click on those questions, we will get the stored answers. That was the old-fashioned chatbots, right? But when AI-based or the LLM-powered chatbots are on the scene, we can actually communicate more easily or more comfortably, like as we communicate with a human being. And in 2025, we have the agentic AI also. So what is agentic AI? It's more using agentic AI, we can create more sophisticated systems. So let's see how the LLM process information. Okay. So of course there will be an input. It may be text, questions, or prompt entered by the users, and it will tokenize. Tokenize. It will tokenize means it will convert into word by word, right? Breaking text to smaller units called tokens, and it will create embedding. Embedding means it will convert these it will convert these text or tokens into numbers. Okay, numbers. So actually, these numbers are used for processing. Actually, these embeddings are then fed to the transformer architecture, and the transformer architecture will generate the output based on the input embedding. Okay, so in this way, actually, the LLM is processing. This is called the LLM pipeline. So we will have the input, then we will have the tokenization, then we will create embedding. To create embedding, we will have we have lot of techniques. Okay, the lot of algorithms are available. Then the transformer will process it, and finally we will get the desired output. So when we talk about LLMs or generative AI, we have we have closed models as well as open models. Okay, so the closed models means it is proprietary, like in the OS. When we talk about OS, we have Windows and Linux, right? The same way, we have the closed models and open models. The open models are, the closed models are proprietary models. The GPT-4, Claude, Gemini, all these things are proprietary models, and we can access these proprietary models using API keys. Okay, they will provide you API using the platform. We can use those API, and we can build the application using those APIs. Of course, there are advantages, because if you want if you want to deploy an open model, okay, the open model means basically the open source models. The Llama by Meta is the best example. But if you want to deploy it, of course, we need a huge computation power. That is the issue, and we have to maintain it. But it is very easy. It is very easy to use closed models, because just go to the interface, create an API key, integrate that API key in your application, then it will automatically call those APIs, and you will get the desired answers. But when you create an application using closed models, of course, you need to worry about the cost. Okay, for each API call, they will cost you. So when you are building an application using closed models, try to minimize the cost. Okay, because they are billing you for tokens. One token means 4-letter word usually. So per token you have to pay, whether it is GPT or Gemini, you have to pay. In GPT, actually you have to recharge first, but in Gemini, you have to pay later. Okay, that is the difference. And if you if you work with a client who concerns about privacy, at that time you cannot use closed models, because you don't have any control in it. You don't know where the data goes, or the provider might have used your user data for their training. That is the issue. That's why when your client is concerned about privacy, you don't have to use closed models. You have only option, that is open models. So Llama is the best example. It is by Meta. Then we have Mistral, and DeepSeek is also there. Okay, all these models are free and open source, and you have all the control. Okay, you have all the control. You can just download the model from the provider, just up it in your system, and you can use it. But to deploy those models, of course, you need a high computation power, especially the GPU systems. That is the issue. And you have to maintain it. The power consumption will be there. The maintaining cost will be there. So before investing, think twice whether you have to choose open model or closed model. So and if you are moving or forwarding with open models, you have some other options like quantization, distillation, etc. So these techniques are used to reduce the model size. Okay. So model size means when you are quantizing a model, suppose the original model is with FP64. FP64 means floating point calculation is 64, up to 64 bits. So you can condense that FP64 to FP4. It may suppose you're building a very small application, no complexity is there. You don't need FP64 model. Okay, your system will be satisfied, might be satisfied with this FP4 model. So in that case, you can condense the model up to FP4, and you can compromise of course, the performance compromise will be there, but you can reduce the hardware cost in a very significant manner. So how to choose a right LLM model? Of course, the most important one is cost. Okay, you can evaluate the API usage. So if you have an option between Gemini and GPT, just go to their interface. You can see the pricing list will be there. Just compare it and you can choose it. And the second one is privacy. So if you are working with a banking client, okay, of course, they don't prefer open model. Sorry, they don't prefer closed models. So in that case, we don't have any other option. We have to choose the closed model. Sorry, the open model. Then accuracy, latency, control, all those things will be based on your application. What exactly you are going to build. Based on that, you can decide which model. There are no specific rule for model selecting. It is purely based on your requirement. Now let's see the architecture behind the LLM, that is the transformer architecture. So the transformer architecture was first introduced in a paper called Attention is All You Need. It was in 2017. So before that, we have RNNs for this, RNNs for the language processing and all. Okay. So at that time, actually, the transformer comes, and transformer has many components actually, but one of the important, or we can call it as the heart of transformer, that is self attention. Okay. And we have multi-head attention also, and it is basically an encoder decoder architecture, and we will have the positional encoding also. We will see what are these things. Okay. Suppose uh, we are analyzing a sentence. Okay. We are analyzing a sentence. Uh, the bank of the river is beautiful. Okay. So at that time, when we are analyzing, we know it is about the river bank, right? So when a system analyzes this, the bank of the river is beautiful. What is the bank? What does the bank mean? So to understand the meaning of bank, we humans usually look at the context, right? The transformer is also doing the same thing. Instead of taking meaning from that isolated word bank, it will check the surrounding also. Okay. The bank of the river was beautiful. So it will check the surroundings also. That is basically called the self attention or the attention mechanism. That is known as attention mechanism. So based on this attention mechanism, actually the transformer decides what to generate or what to create. Actually, we humans do not take meaning from each and every word. Okay, if you have a sentence, we will read the sentence entirely, then we will understand the meaning. Okay, we are not taking meaning word by word meaning. Okay, but before transformer, it the meaning was identified word by word. But we usually, the humans, understand the entire sentence, then we will understand the word. Suppose the sentence is like, I went to bank to deposit money. Okay. So in that case, we know that bank means truth. But if it is like, I sat on the bank of the river, so we know that bank means the river bank. So the attention means, or self attention means identify the meaning. Identify the meaning by paying attention to other words. Okay. In simple way, we can say that understand the meaning of a word by analyzing its surroundings or analyzing other words. That is basically called attention mechanism. So we can visualize the transformer architecture. So as we have already mentioned, transformer is a encoder decoder architecture. It has the encoder as well as the decoder. Okay. So how it works means, suppose we have an input text hi, and we want to convert it into French. Okay, French. It's a very simple example. So hi is the input text, then it will encode, then the transformer architecture will do some processing, then it will decode, and finally we have hi in French. Okay, so in that way, this encoder and decoder will work together. Usually we will use these things for translation, summarization, and text generation. But the modern LLMs, so we are familiar with GPT, Gemini, etc. They have used only decoder. Why? They are only generating, right? They are only generating. That's why it is using, we can call these models are decoder only models. And when we are talking about the transformer architecture, basically we have 8 building blocks with us. The first one is tokenization, second one is embedding, then we have positional encoding. You can see it in the diagram. Okay, we have input, we have actually tokenization will be here, then input embedding, and we have positional encoding. Then we have self attention, then multi-head attention. Then we have a feed forward network. And of course, we have some normalization layers. And finally, we have the output also. Okay, the output probabilities. So we will see what are these components. Suppose the input text is how are you? How it contains 3 words, right? How are you? So the first step, tokenization means it will divide the sentence into words, or we can call it as tokens. So we can say how is a token, R is a token, U is a token. Okay. So we can divide the word into number of tokens. That is basically the first step, tokenization. Then we have embeddings. So the embedding means we will convert these tokens into number representation. So for number representation, we have many methods. Actually, the OpenAI is giving you some embedding techniques. If it, and Llama is giving you another embedding techniques. So if you, according to your convenience or your your results, you can use any embedding techniques. So after the second step, okay, after the second step, you will have the number representation of your words. Okay, number representation of your words. Then you have the positional encoding. So in the positional encoding, actually in this, we want to we want to derive the meaning of the sentence by analyzing the word and also its surroundings, right? So for that, position is a matter, or position is a very important factor for deriving the meaning. That's why for each word we are encoding its position also. That is known as positional encoding. So after positional encoding, we will have the embedding representation of the word as well as the position. Okay. Then we have the self-attention. So in the self-attention, each word look around to other words. Okay. Each word compare with the other words, look around to other words, and it will decide. Okay. It will decide which word is prominent in that sentence, or which word is important to me. Each word will decide which word is important to me or more connected to me. That is happening in self-attention step. And for each word, it will have a query, it will have a key, and it will have a value also. So compare it with all other words available, then each word will calculate its relevance score. Okay. So suppose score is very low, we can discard those words and we can focus on more important words. That means after self-attention, it will calculate, each word will calculate how much relevance I am, and it will have a relevance score also. So that relevance score, based on that relevance score, okay, we will decide, okay, this is the important word. Okay, we will, and ignore less important word. We will focus on more important words only. We will ignore less important words. And we will do this attention passing or attention calculation many times. That's why it is known as multi-head attention. Okay. So it may be based on the grammar, meaning, subject word relation, context, etc. Okay. So after doing all these things, actually, the relevance is calculated. Okay. So now we have the word embeddings, position embedding, then the relevance also. Okay. And we will give all these things to their pattern. That means feed forward network. It is a simple neural network architecture. And it will learn. Okay, it will learn the things. And as same as in the deep learning techniques, we have some optimization or normalization layers, and it will generate the output. Okay. And all platforms, OpenAI, Google AI, the Gemini, Anthropic, Meta AI, DeepSeek, then Grok. So all these all these platforms are using basically this transformer architecture. Okay, you know that these are the leading platforms. You're already using all these things. And we will see or we will discuss some LLM limitation also. So one of the important things that is hallucination. You may have heard about hallucination, right? So what is hallucination? Hallucination means the LLM will give you the wrong answers. The LLM will give you wrong answers with very high confidence. That is the issue. Okay. So they don't know whether it is right or not, but it will give you the answer with very high confidence, but it may be wrong. That is the main drawback of hallucination. You can control hallucination up to some extent using prompting and all. Prompting, then there are some parameters like temperature. So if you give temperature near to zero, that is near to zero means like 0.01. So in if you give like that, you can control hallucination up to some extent. Okay. So the temperature zero means it we will restrict the creativity. If the temperature one means we are not restricting the creativity. Okay. So if you restrict the creativity, we can control hallucination because it won't it won't hallucinate. But we cannot say that. We cannot say that it won't hallucinate, but sometimes it will hallucinate if the temperature is 0 or 0.001. But we can control it. And the second thing is training data bias. Of course, the historical bias are there because these algorithms or these models are trained on a very huge amount of data. If there are some bias in the training data, then of course that bias will be there in the model inference also. So especially if you ask some controversial political thing related to US to GPT or Gemini, it won't answer properly. At the same time, if you ask the same thing related to China to DeepSeek, it won't answer. That means the training data bias is there. And privacy and security. If you are okay, if you are using closed models, we don't know where our data goes, what they are doing with our data. So the privacy and security is another important concern. And the computational cost, the API cost for each and every call, and for the large scale deployment, if it will cost very huge. And we need a huge significant or we need a significant investment. And context window limit that is solved up to some extent because initially the context window size were only 1024. Now we have 128K and more, right? So that is not a big issue right now, but even though for long documents, if you want to process or extract data from very long document, still context window is size. We can use chunking and all, but still it is an issue. And explainability, that is another important thing. So if you ask the same question twice, you will get two different answers, right? So when we are working in an industry, if you are building a system using LLMs, the client may not aware about the LLM limitations, LLM challenges. So if you deliver a product to client, it should work in 100% scenarios that actually the client is expecting. But in many cases, LLM will be a key or core component of our system. Okay. And when LLM hallucinate, or LLM give you wrong answers, we cannot do anything. We, we can strict the prompt, we can change the parameters, that's okay, but we cannot do beyond our limits. So we don't know how they are taking decision. Suppose we are building a object detection system using YOLO or something, deep learning technique called YOLO. And if an image fail, what we can do? We can add the failed images to our data set. We can fine tune it. And of course, we know in the next iteration, the system will detect those failed images. So that's those kind of things cannot do in LLMs. That is the another challenge we are facing. And when implementing we can follow some best practices. When we are deploying a system, initially there should be a human in the loop. We should validate. We should validate the fact that is given by the system, and we can we can test up to some extent. Okay, so we have already seen what is generative AI. Generative AI means it can generate something, and it can generate some not something. It can generate text, video, images, audio, code, etc. Okay, and we have seen the model behind the generative AI is large language model. Then we have seen the architecture behind the large language model is the transformer, right? Now we have the architecture, the model, and the platform, right? The next thing is how to communicate with these models or how to communicate with these platforms. So we call it as prompting, right? So if we want to ask something to GPT or Gemini, we usually call it as give the prompt, right? So if we give good prompts, good what is good? Good prompt means the prompt should be precise for, and it must contain all the required information. Then only you will get the desired output. Suppose you have an intern, right? Suppose you have an intern, marketing intern. You said to him, just give me the report. He will give you the report 99% of the time. It won't be useful, right? Instead, give him a clear-cut instruction like, give me the report of these things. You can, you will get these things from these areas or these portals, etc. Then you will get a very decent report from your intern. So how the quality differs? The quality differs on your instruction, right? You have given two kinds of instruction. For the first instruction, you got a bad quality product. For the second instruction, you got a very good quality product. In the same way, if you give a very quality prompt, you will get a very good or the desired output. We can say that the desired output. And then there are a lot of job opportunities like prompt engineering and all are coming, and prompting, and also the prompting or the English is the, when if you are the programmer, you can see that the English is the new age programming language. Okay, so if you know how to prompt in a perfect manner, you can create any product according to your idea. So in prompt engineering, we have a lot of techniques. The first one is zero shot prompting. Then we have few shot prompting, then chain of thought prompting, then role prompting. Then we can include structure output, and another technique is called RAG. You may heard about the retrieval augment generation, right? That is not a prompting technique, but it's a technique related to LLM. So we will see each technique one by one. So the first kind of prompting is zero shot prompting. So zero shot prompting is the most straightforward technique. Okay. So if we give some prompt, then it will give you the output based on LLM's knowledge. So we are not giving any prior example. We are not giving any examples or scenarios. We are just giving the content, or we are just giving the prompt. You can see the example. Translate to French. Hello. Then of course the model will give you the one job. Okay. Without for that they don't need any samples. So if you want to perform these kind of simple task, you can follow zero shot prompting. In zero shot prompting, we are directly give the prompt. We will directly give the prompt and no need of examples. The second technique is few shot prompting. So using few shot prompting, actually we can control the hallucination also. That means we are actually teaching the LLM that okay, this is the context. Okay, this is the context. Then okay, these are the examples. So based on the example, it will give you the answer. It will give you the answer for the query. So here you can see in the example, a user prompt. Identify the primary emotion. I am so happy today. And we have given it. The emotion is joy. That is the thing we have given. Then we have given another example. Identify the primary emotion. This is frustrating. Emotion is frustration. Okay. Then we are asking what the next question. Identify the primary emotion. I feel incredibly sad. Then it will give you the sadness. It will give you the answer like sadness. Okay. So this is a very simple example. Actually, to do this, actually you don't need examples. But in this way, you can give examples in the prompt. So based on the examples we have given, it will answer for your query or it will answer for your prompt. So the next thing is chain of thought prompting. Okay. So in the chain of thought prompting, it will execute step by step. Okay. So we are instructing LLM to do it step by step. Or otherwise, we can give, okay, you should follow these steps. So in these two way, actually we can do chain of thought. One thing is give the LLM the instruction to think step by step. So here you can see if a train, the prompt is if a train leaves city at 9 a.m., traveling at 50 miles per hour, and the city B is 20 miles away, what time will it arrive? And we have added one more word, one more sentence that is think step by step. So it will produce the output like this. Okay, distance to travel 200 miles, speed of the train 15 miles per hour, then time taken, distance by speed 200 miles by 50 miles per hour, it is 4 hours. So the departure time 9 a.m., arrival time, departure time plus time taken, that means 9 plus 4, 1 p.m. Therefore, the train will arrive at 1 p.m. So in this way, it will think step by step as we think. Okay. Suppose we have these kind of questions for our exams or tests, we usually derive the answers like this, right? In the same way, in the chain of thought, it will derive answers by thinking step by step. So we can do in chain of thought in another way also. That means we can include all these things in prompt itself. Like, okay, follow these steps. First, calculate the distance to travel, then speed of the train, then time taken, then departure time. So if we give the instruction like this, then also it will follow the instruction. In that way also, we can we can do the chain of thought process. Sometimes um, when we are trying to retrieve information from some database or PDFs, and if you use the straight prompting like few short prompting, it won't answer. It won't give you the desired answer. So at that time, of course, you should use the chain of thought prompting. And role prompting is also there. That means first define the role. That means just tell the GPT, okay, your role is this. Then explain based on your role. Okay. So here you can see you are a senior doctor explaining a complex medical condition to a patient. Describe symptoms of diabetes in simple terms. Okay. So I want to, so you will get an answer. Suppose you are setting a role like you are a senior lawyer. Okay, you are a senior lawyer. In that case, it will give you answers how a lawyer is behaving or lawyer is replying to your query. Okay, so role prompting is also important. So when we are building a system for financial institutions, okay, then you can set a prompt like or role like you are a banking official. So it will view the data or it will understand data and the data based on the role you have set. Okay, then the next technique is not prompting techniques. Okay, we can say that as a prompting techniques. Sometimes sometimes we need the outputs in a very structured format. Okay, so especially when you are building a system and that should be integrated with any external systems. Okay, the external system has a specific the external system has a very specific output format that can. Okay, so in that way usually we know the output, yeah, the external system will accept output maybe in JSON format or a specific table format, etc. And you are creating an output using LLMs, and LLMs don't know in which way actually you require the output. So in that case, what you can do, you can specify, okay, I need the output in this particular format. So here you can see the extract the following information from the text below as a JSON format. Usually we will use JSON in software development. So it will extract the required information in a JSON format, and that can be integrated with the external systems. And so the next important thing is RAG, retrieval augmented generation. So the retrieval augmented, give me a second. I need to have some water. Okay, you may have heard about this one, right? The retrieval augmented generation everywhere when you when you write, when you read a blog, when you read something in a LinkedIn, you can see the RAG approach, right? What exactly RAG? So we have the LLMs and we have the prompting techniques, right? So initially what we have done, we are directly giving the prompts to the LLM, then it will give you the answers, right? But suppose you want to build a system that the GPT or the Gemini don't know. It may be your internal information or some specific PDFs or some specific database or some knowledge base. Actually, these are the publicly available LLMs don't aware about these knowledge base. Suppose you want to create a system that can give you the answers based on your office policy. Like suppose you ask how many leaves are there in my office? Annual leaves are there. How many sick leaves are there? GPT can't answer because they don't know your internal policy. So if you want to integrate the external source with this LLM, we can call it as RAG. Okay. So in that case, we will connect the external sources. It may be a PDF, it may be an Excel, it may be a slide, it may be a database, it may be some other portals. Okay. And we will connect all these things with the LLM. And we prompt using any of the prompting techniques that we have discussed. Then if we ask what it has done, the LLM will process your query. At the same time, it will fetch the information from the data source that we have already connected, then fetch the appropriate information, and it will present to you in a very presentable format. It will give you the answers in a very presentable format. So here you can see an example. Based on our internal policy document, what is the maximum expense reimbursement for client dinners? Okay. So if we ask a question like this, GPT won't answer you because they don't know your office policy. So it will retrieve the relevant information from the internal policy document that you have given, then extract the specific information, then given you the response. So if you build a system like this, we can call it as RAG, retrieval augmented generation. So how to build an app or application with LLMs? So very basic application, very many complexities are there when will be there when you build a system. But I will tell you the basic flow. Of course, the first thing is user request, and the final thing is response to the user, right? And in between, the second step, the application will process. Okay, so it will take the user input. So multiple inputs are there, will be there for an LLM. So one is user input, and we have already integrated many data sources. So it will fetch the information from the data source, and it will extract the context, and the application will process it, and the LLM will give you the answer. Okay. So the basic flow is the user request, then the application processing, the LLM inference, and finally the response to the user. So to build an application with LLM, you might need some libraries. Okay. Of course, yeah, it will be very easy to build system using Python. Okay. So Python will be our programming language in most of the cases. And you can create this application in an REST API format. Okay, to that it will be better to use fast API if you are using Python language. Okay, so Python is the programming language. Then fast API is the REST API framework, and for LLM you have to use an LLM orchestration framework. Okay, so the LLM we have multiple LLM orchestration framework. The the most important one is LangChain. Okay, you can use LangChain. And another important one is Llama Index. You can use whether LangChain or Llama Index according to your convenience. The advantage of using these frameworks are it both frameworks, the LangChain and Llama Index, both have lot of predefined things. Okay, that means suppose you want to ingest a PDF to the LLM. There is a predefined function. Suppose you want to connect a database. There will be a predefined function. Suppose you want to call an LLM. There will be a predefined function. So all these things will be, or all these things are already defined in both LangChain and Llama Index. So just check both LangChain and Llama Index, then identify your convenience, and according to your convenience, you can select either LangChain or Llama Index. So the next one is VectorDB. So VectorDB is one of the most important component of LLM application. So when we are building a RAG application, we will have documents. Suppose we have some PDF documents with us. We will convert those PDFs into tokens. Then these tokens will be converted to embeddings. Okay. So then these embeddings will be stored in a DB or specialized DB called VectorDB. VectorDB. So when user prompts something, okay, or when user asks something, those query will be converted into embedding. Now we have all the data in embedding format that is stored in vector database. Then we have the query that is also in embedding form. So this query embedding will be matched with the embeddings that is available in vector DB. Then find the appropriate answer and it will give you. Okay. So to store this information, to store this embedding, the specialized DB called vector DB is using. Okay. And of course, if you want to build, you can build a UI also. So while creating an LLM application, the first thing is get question, retrieve data, then create a prompt based on the data and question and the prompt. You can call LLM and it will give you the answer. So now we have already seen what is generative AI, the model behind generative AI, that is LLMs, then the architecture behind the LLMs, uh, called transformer architecture, then how to communicate with the LLMs, that means prompting, then how to build an application, simple application, that means RAG. Okay, so we have already seen these things. Now we will see the latest trend, that is agentic AI. So when we talk about agentic AI, what exactly a agent do? The main difference is when you're building a RAG system, you are giving some prompt, it will fetch the information and it will give you. It doesn't think, right? It doesn't think. So when we are infusing this thinking capacity in the RAG or the LLM application, we can call it as an agentic AI system. So before agentic AI, it just responds to your prompt. But here in agentic AI, it will think, it will execute, it will plan, and it also learn from the mistakes. Okay, that is the power of agentic AI. So LLM initially, as I have already mentioned, the LLMs that give you the answers to the question, right? But in AI system, agentic AI system, they are actually designed to plan. Plan means autonomously plan, then execute, then think, use tools, execute complex and multi-step tasks without human intervention. So initially we have LLMs, right? Initially we have LLMs, then we have integrated many tools in LLMs. Okay, that means tool calling was there. If you build a system in 2024 or 23 last, you can say you might have seen that the tool calling was there. And now we have the agentic AI. Okay, the agentic AI system itself think, they will plan, they will execute, they will learn. So these are the 4 steps in agentic AI. The first one is when you give a task, first it will create a plan. Okay, that means it formulate a strategy or sequence of action to move forward. Okay, or it will create a plan to achieve the goal basically, and based on the plan, it will act. It might contain tool calling or whatever the things it required. So it will so in the planning itself, uh, it will be there. Okay, you need to call all these things. So based on the plan, the act will call all these tools and give you the result. Okay, and the next step is observe. The observe means check, it will check or it will perceive the current state, the new information, and user input. So in the observe stage, it has the new information or new output, the current state, and whatever may be the things it has, all things will be there in the observe. And then it will think, okay, is this the real output I need? If it is no, it will it will understand the mistakes. Okay, it will understand the mistakes. According to the understand, it will update the things. Okay, then execute again. So it will understand from the learning. So the four steps or the four key components are plan, execute or act, observe, think. Think or reasoning. We can call it as thinking or reasoning. So for an agentic AI system, we need a tool calling or function calling thing to interact with the external things. And we need we need to understand from the past thing, right? The past conversation. For that, we need the memory. Okay. I think we will have a session on the memory day after tomorrow, and the chain of thought and self-correction will be there. And and we have lot of frameworks for agentic AI. LangGraph is there, Crew AI, AutoGen by Microsoft, and OpenAI Swarm. So these are the leading frameworks for agentic AI. You can use any. I prefer LangGraph because it is very easy to use for me. Then, as I have already mentioned in agentic AI system, suppose you have to build an assistant. Okay, you have to build an assistant, and you are communicating with the AI assistant you have. Suppose you tell book a ticket from Cochin to Mumbai. Okay, book a ticket from Cochin to Mumbai. Okay, book a flight ticket from Cochin to Mumbai. So in that case, first it will plan. Okay, it will plan what are the things to do. So the things means it need to identify. Okay, I need to identify the source, destination, then flight routes, then flight fare, then once the prices are confirmed, you need to use payment gateway, and finally the confirmation mail, right? So these are the things to be done. So to do all these things, the first thing is you have to communicate with a flight booking system or flight booking system that may be available. And To do the payment, you have to communicate with the payment gateway or the bank server. And to write the notification mail, communicate with the you have to communicate with the mail provider, right? So what usually we do to build a system like this, we have a framework, maybe a lang graph to call this tool, okay? Or to call this service, we need to write glue codes. We need to write glue codes. There should be a glue code for calling the flight booking app, right? There should be another glue code for calling the bank server. Another glue code will be there for writing the email, right? And we have built the system, and suppose we assume that the system is working 100% fine. But what is the challenge? The challenge is there. Suppose the flight booking app changes its request and response format or any schema they have changed. What will happen? This system will fail because there should be a standard request response structure, right? So if if the flight booking app changes it, our system cannot communicate. Okay. And we have to rewrite the code. And again, suppose it is working 100% fine. At that time, bank changes. Again, the system fails. And we have to rewrite the glue code for bank. So in that way, every day we have to rewrite the code, especially the glue code. Where actually the application of MCP comes, the Model Context Protocol. It is a standardized communication framework, okay, for agentic AI. Suppose our flight booking app, it has an MCP server, okay, it has an MCP server. Suppose they have built an MCP server. So in that case, we have to communicate with that MCP server only, okay. We just communicate with the MCP server using the standard protocols, and we will get the response using the standard MCP protocol. Who actually releases the MCP server? The app itself, the flight booking app itself provides the MCP server. So if they make any changes in their system, they will automatically change their MCP server also. So our system won't fail. Okay. And suppose we have for the email notification, we are actually communicating with the Gmail, right? And suppose the Gmail has an MCP server and we are communicating with that Gmail server, Gmail MCP server. Gmail has changed something. Of course, they will update their MCP server also. So our system won't fail. So there will be a standardization for the communication. There will be a standardization for the communication to understand, interact with the external tools or services. For that standardization is actually done by MCP, that is Model Context Protocol. It will help you to standardize interoperability and reliable tool usage. Actually, we can minimize the glue code. Okay, we can minimize the glue code between our agentic system and the external thing. So we can minimize the glue code and it won't fail in that 99% of time. In the previous case, that means before MCP, the system may fail in 60 to 70% times. But when MCP are on the scene, we can create reliable, scalable systems. So MCP can use to interact with the files and documents, the external APIs, the external database, or the external enterprise systems. Maybe CRM, ERP, project management tool like Jira, coding platforms like GitHub or GitLab. So anything. So as we have seen the LLMs, there should be a flow for agentic MCP and agentic AI. There should be an LLM request. Then MCP translate this LLM request to a standardized tool code. So what the MCP will do, MCP will convert this into a standardized. Then proper interaction will be there. Then tool execution based on the instruction from the MCP server, the external tools will be called. And based on the tool execution, the real world actions will be done. The best example I have already mentioned, book a flight and email me the details. Suppose I have an agent. I told the agent, that means the agentic AI chatbot with me. It may be a personal assistant. I just told the agent to book a flight ticket and email me the details. So of course it will search, it will compare the prices, then it will book, and finally it will notify to your inbox. So all these communication to the external system will happen through the MCP server. So we will quickly see some industry examples. LLMs can apply in any areas. So we will focus on some of the important application areas. So one is BFSI, banking and finance. The second one and insurance. Then second one is healthcare. Then automotive, legal, and education. We will see some use cases, simple use cases. So in BFSI, lot of applications are there. So these are some important applications. One is fraud detection, then risk assessment, and customer service. And if you can do all these things using LLM, the impact will be very high. And the healthcare, especially for drug discovery, patient engagement, all those things you can use agentic AI. And of course, in automotive, autonomous driving, predictive maintenance, and supply chain also, we can use this. And one of the niche and untouched area is basically legal. We don't have that much application. We don't have, we can say very few applications are there in the legal side using AI, but a lot of potential are there. So we can use AI for contract review, legal search, the case production, etc. And of course, in education, a lot of applications are there, like personalized learning, content creation, and admin automation, etc. We will see one examples each for each sector. So in banking, LLMs can be used for identifying financial fraud. So actually, a lot of transactions are happening in a second. So these LLMs can continuously monitor this vast transaction streams. And these LLMs can automatically flag the suspicious transactions. Then it can easily identify the suspicious transaction, and dynamic scoring can be done using LLMs. For each thing, we can develop different agents. So actually, the JP Morgans have significantly cut this fraud alerts to 25%, reduced false positives actually by JP Morgan if they have implemented these LLMs for identifying financial fraud. And another important thing is it can process up to 1 million plus transactions per second. And if you have implemented all these things, 1 to 2 millions can be saved in a year actually. Another important application, in nowadays banking in every banking sites, you can see the LLM based LLM powered chatbots. So you can interact with the LLM powered chatbots as in the same way if you are communicating with a human being sitting other side. The main thing is they can cut the cost and it will be available 24 bars. So if they have adapted the LLM, actually the complaints accuracy can be increased up to 95% according to the studies, and cost savings up to 20 to 30%. In healthcare also we have a lot of applications from the healthcare system. Lot of data is there, and if the LLM process it, we will get the actionable insights. Actually, the clinical diagnosis, note summarization, etc., can be done using LLMs. So when a doctor is diagnosing a patient, his notes, his speech, everything can be recorded, and later it can be summarized as a note. Okay. Actually, Mayo Clinic and all are currently using, or they have adopted LLMs. And if they use LLM in healthcare, the diagnosis will be around 25% faster. And according to the studies, by 2030, the ROI with LLMs will be around 100 billion. And of course, the return will be 3x according to the studies. And I'm sure you're very familiar with this use case, that is autonomous driving. So that's why I'm just skipping this. And as I have already mentioned, one of the important area that is untouched is basically legal. In legal, we have lot of documents actually. Actually, we have some clients in legal side. So they have a lot of documents and they need to process all these documents. Actually, document overload. Each legal office is flooded with documents. That is the current scenario. And if you are able to solve it, there, should, there will be a very huge potential for it. And basically, the contract and drafting, they can be, they're investing a lot of time for drafting the cases, drafting the legal, drafting the documents, right? So for that, so this All these things can be automated actually. Then case prediction can be done, automated review can be done. If once the document comes, they can automatically review the document, they can identify the gaps. So a lot of potential is there in the legal domain. And education, of course, the next thing is education. So in education, the personalized personalized learning and tutoring can be done. That means each student is different. And if a class if a class contain 30 students, 30 students, each and every students will be different, and there may be some students they need high attention. So to so if sometimes the teacher don't get enough time to give that extra attention. So if there is a virtual teacher that may be a clone of this teacher, then the student can access this virtual teacher anytime, and they can seek help from the virtual teacher 24 bar 7. So of course it will help the student to improve in a very better way. Then of course that content creation and everything can be done using LLMs. So before winding up the session, so if you adopt the if you adopt the LLM, or if an industry adopt an LLM, the it will increase the operational efficiency. That means it can reduce the cost, and at the same time it can improve the performance also. And lot of practical applications can be created. But while creating the application, you will be very careful, because you need to consider the ethics. That means no a bias will be there. You have to consider the privacy things, and you should be very transparent. Okay. And if you want to create an application, first you just create a pilot application, then measure its performance and iteratively improve the performance. And the future of the LLM multimodal is already there. You can use this multimodal in your application. Then edge deployment can be done. Actually, there is an LLM model called Gemma by Google. 1 billion model is there. Performance is of course very low, but it can be deployed in mobile devices. Okay, so for such applications, the edge device LLMs that run on edge devices also already available, and of course the performance will be improved. Okay, and you need to adhere on ethical things. And if you want to start your LLM implementations, of course, for more sessions will be there in the remaining days. In those sessions, they will handle the programming thing, the frameworks, then the memory related things, how an application works, etc. Okay. So, but if you want to start your LLM journey, first you need to identify a very high impact use case in your domain where LLM can use. Okay. Sometimes there may be a use case, but LLM won't be useful in that use case. Don't pick that kind of use case. Pick a use case where LLM perfectly fit. Then build the application. Okay, then build the application, then start the pilot programs. Then, of course, you train it with the employees with the system you have built, and finally you can partner with the experts. Then, in that way, you can improve your system. So, simple thing we can do is identify use case, build the system. That these are the two steps you can do. Okay, the later things, if you want, you can follow. So, with this, I'm just winding up the session.